I do want to ask you one very hot question all AI founders ask me. Where is the revenue pocket for a startup founder to build startups in robotics? What are the hot pockets to target?
Right. I think there are really like three layers that we can think about. One is the hardware enablement layer, like NVIDIA, a robotic hardware, a motor. They're solving different problems.
Yeah.
Then you can think about it in a vertical manner. So for most robotics founders, it pays to be hyper focused if you are solving an end solution.
But you're not.
We are not. So we are taking an interesting position that we happen to be experts in AI for robots. So we have built a generalized model that can help numerous companies across the board, but we are strictly taking a software-only approach at Torque AGI.
So you're a platform.
We're a platform. We have a layer on top of NVIDIA, a very powerful layer. NVIDIA is our hardware enablement simulation partner. We are building models that send end-to-end problems, but there is still a software component for the vertical robot solution builder.
Wonderful. So, Dr. Saxena, you visit many universities, even though you were assistant professor in the past at Cornell. What are your engagements with universities like, and what kind of founders are you finding in the universities these days?
So I think there's a lot of innovation happening at universities. As an example, I am still sometimes on the PhD committee of a Stanford professor. There's Professor Ehsan Adeli, who is building healthcare tech and revolutionizing it, working at Casper with it. We actually are sponsoring a robotic science and systems workshop. 10 years back, we wrote a paper which brought deep learning to robotics for grasping. And with Professor Ran Salu at Arizona State University, we are inviting professors from CMU. We are really answering the question, when you're building foundation models for robots, how do you make them reliable? How do you test them?
Amazing. And looks like foundation models, understanding them, what they look like in the physical world, that's like challenging. Foundation models are going to be multimodal, is that right?
Oh, by definition, yes. And that's the challenge, because the current AI models are discrete tokenization of text.
Right.
And robotic data happens to be spatiotemporal and continuous, and it's not exactly clear how to embed planning and control into the same model, which is what an area of innovation.
Wonderful. So some of the most respected investors in the Valley have invested in robots much ahead of other people. For example, if you look at Vinod Khosla, he invested in OpenAI, but then even before that, he had been talking about bipedal robots. So tell us, what are these humanoid robots you are able to co-actively train? That's the term you have introduced. What are they doing differently? Why are the investors betting on you?
Yeah. So traditionally, they have a supervised learning where you teach a AI model what to do. You can also have reinforcement learning with human feedback. But both of these methods are really dependent on human data or human to teach a robot what to do. When it comes to physical AI, it turns out robot can be an active participant in their own learning, because they are acting in the real world and they can choose to do something to learn.
So give me an example. Let's say you want to do active learning. Let's say the robot in setting up the set. How do you train it to set up?
Let's take a factory example. A humanoid robot is going, it is trying to unentangle a box and put it from one place to another. It's coming in a pile, that kind of a sorting environment. And for some reason, let's say there is a package, it doesn't know how to handle bendable packages. They get messed up, right?
Absolutely.
So what it can do is that it can actually take an action and start playing with it. And that it can make a choice to learn about it.